Hello everyone, this episode of Drawing Lewis Structures is brought to you by cyanide ion, which is one of our polyatomic ions. It has the formula Cn with a 1- charge. So I've got only one carbon, one nitrogen, and a 1- charge to work with. So again, let's follow our steps. The first step is to sum the total valence electrons that we have. Carbon is in group 4, so it has 4 valence electrons, and nitrogen is right next to it in column 5. And again, because we have a 1- charge, we're going to bring down and add 1 to the total. So I have an even number now. 9 plus 1 is 10 electrons. So somehow I have to use up 10 electrons total to give both carbon and nitrogen an octet of electrons. So let's get started. Now here we have used typically the element written first goes in the middle. But in this case I already just have only one other atom to deal with, so I'm just going to put them next to each other and connect them with a single line. Alright, so then let's say we go to the second step, and that's our skeleton structure. Step 3 says use up some more electrons to give the outermost atoms, which in this case is both of them, 8 valence electrons. So I've used up 2, 4, 6, 8, 10. But now I've used up all 10 electrons. And at this point I don't have any extra electrons to put anywhere. I've actually just run out. And this is the situation when you've run out of electrons and you need to make an atom happy, then you have to start doing double or triple bonds. In this case the nitrogen only has 4, but carbon over here has 8. So let's try a double bond. Let's take one of these away and make it into another line connecting the two atoms. This keeps those electrons associated with the carbon, so we still have 2, 4, 6, 8. And now the nitrogen has moved closer to an octet at 2, 4, 6. But again, it's not there yet. So what do we do next? Well, the carbon and the nitrogen can share only one pair, they can share 2 pairs, they can also share a third pair. So if I were to bring this one in and make it a triple bond with one lone pair on each end, now each of the 2 atoms has 8 electrons associated with it, 2 on the end and then 6 that are shared equally between them, at least at this point. Alright, and so I've used up all 10, but I've made each atom feel like it has 8, and the last thing I need here is just a bracket and the charge on the outside to again show that it is indeed an anion. Alright, so once in a while you'll see a triple bond that needs to happen. Alright, and that's that episode.